Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So in the lecture series of Fundamentals of Mechanical Engineering and Mechatronics, which is the first year subject, this time I am covering the topic related to hydraulic accumulator, and hydraulic lift. So these two devices I am going to cover in this particular video. So what basically the accumulator is? Accumulator, by the name it is very clear, accumulating something. And here we are talking about the accumulating of energy, hydraulic energy, through which we can perform certain application. So in mechanical engineering, this is the purpose. So we use different types of energies, different types of powers, and by accumulating these kind of energy, we can run many applications. So this is what the simple purpose of hydraulic accumulator. Okay, so what basically the hydraulic accumulator is? It is a mechanical device used in hydraulic applications. Hydraulic applications such as it can be a crane, it can be a lift, it can be a press. So the devices which are running on hydraulic power, which are running on hydraulic energy. So for that purpose we need some accumulation of hydraulic power. So for that purpose this hydraulic accumulator is used. So hydraulic accumulator is basically a mechanical device used for certain hydraulic applications. It is not actually the device which is performing the actual working. Then what it is? It is basically the intermediate device. So it works as an intermediate device between the supply lines of hydraulic fluid from pump. So pump is performing what function? Pump is increasing the pressure of hydraulic fluid and it is used for certain purpose. So it is working as an intermediate device between pump. So from pump we are receiving the high pressurized fluid which is used for certain purpose and to required machines which is running on that. So in between the hydraulic pump and the machine, and that machine can be a hydraulic press, hydraulic crane, it can be a hydraulic lift. So in between hydraulic pump and these devices, one accumulating device which is storing the hydraulic energy can be used. It is not the permanent storage system, it is a temporary system. So it temporarily stores the pressurized hydraulic fluid when operating machine is in idle condition. So when the operating machine is in idle condition, it means it is not requiring the hydraulic power, it is not requiring the sufficient hydraulic energy. So some part of energy is still available and that some part is utilized as a temporary store. So that is what the hydraulic accumulator is doing. Okay, pump continuously. Pump is doing what? Either it is a reciprocating pump or it is a centrifugal pump. Pump is continuously delivering the energy, high pressure fluid, and if that much amount of fluid is not required, that much amount of energy is not required for the certain applications, then that energy is getting stored. So that is what the hydraulic accumulator. Now I am coming to the working and the construction of the hydraulic accumulator. Very simple working, not a very difficult or complex one. Here we can see a simple arrangement, a piston or ram is there which is reciprocating, which can be reciprocated in this fixed cylinder. Okay, so what this side is connected to the pump from where we are receiving the high pressure fluid. High pressure fluid through the pump is coming here. There is an inlet valve. If the power is required by the hydraulic machine, which can be a hydraulic lift or it can be a press or it can be a hydraulic crane, then the high pressure fluid is transferred directly to that device, to that application through the outlet valve. But if the machine is in idle condition, or if the amount of power, amount of energy, amount of pressure developed by the pump is more than the requirement, then what will be done? Then obviously that high pressure fluid is forcing this piston to move upward. So this piston is moving upward when the power is in excess, when the energy is in excess. So it is moving upward, and in its upward movement, what it is doing? Basically it is storing the energy, it is storing the potential energy. And one more arrangement we made here, that is the putting some weight. So putting some weight, what we are doing? We are basically increasing the mg, we are increasing the mg. So we are increasing the potential energy. So that's what the simple working. But in which condition? When the power requirement, by the application, by the machine, or the energy requirement by the machine is less, in that condition that piston is moving upward and the potential energy is getting stored, accumulated here. So this is what the, so that's what written over here also. A simple hydraulic accumulator consists of a cylinder with inlet and outlet ports for the hydraulic fluid. Inlet are attached with the pump, as I already told, whereas the outlet is connected with the operational machine, which can be a lift, which can be a press, anything else. Cylinder consists of a ram with reciprocating motion inside the cylinder and having some weight on the top. So all the points I made clear. The arrangement of the ram and cylinder should be vertical in position. Okay. Now the pump is doing what? Already discussed. Pump continuously supplying the hydraulic fluid to the operating machine through the accumulator. When there is no requirement of the fluid, the outlet becomes closed. So whenever the idle condition of the machine is there, in that condition that outlet valve is closed, or the energy requirement of the application is less, in that condition that piston is moving upward. So in that condition we can see the piston is in upward condition. So it is having more potential energy as compared to the previous position. Now what will happen? When the requirement of the application, which is connected on the outlet side of the hydraulic accumulator, and the supply from the pump is lesser, if pump is supplying less energy to the application, so in that condition that hydraulic accumulator will fulfill the requirement of that energy. It will bridge the gap between that. So the time continuously supply from the pump raises the ram plunger in the upward position gradually till the extreme end, or until the outlet is open. This operation helps to store the hydraulic energy. Already told, whenever the idle condition is there or the supply of energy is more, in that condition it is going upward up to the extreme limit. As the operating machine, now we are coming when the power requirement from the machine is more, or the lesser power, lesser energy is supplied from the pump. In that condition what will happen? In that condition the operating machine require pressurized fluid for the power stroke. Then the outlet port becomes open and ram with weights on the top starts coming down and bridging the gap and delivering the energy and delivering the power. So that is what the simple working of the hydraulic accumulator. I hope it is very simple in construction, very simple in discussion. If the diagram is not clear here, then we can see that diagram. This is the hydraulic accumulator, inlet valve, exhaust valve. We can write here, this is the pump side, this is the application side, hydraulic machine is there, this piston or the ram is getting reciprocated, the weight is placed for the purpose of increasing the potential energy. Okay, so in that condition, so that diagram we can draw whenever the hydraulic accumulator is asked in our exam. So hydraulic accumulator, accumulating the pressurized fluid which will be delivered whenever it is required by any hydraulic application such as press, lift or crane. When the supply from the pump is less, in that condition it bridges the gap. So again I summarize that part. Okay, now we are moving to Some more applications of hydraulic accumulator, although, so it stores the hydraulic energy, that's what is clear to us. Okay. So first is, it is storing the hydraulic energy. As we studied above, the most important function of any hydraulic accumulator is to store the hydraulic energy and transmit it further when required. Okay. By doing this, what basically it is doing? It is reducing the vibrations and shock. Okay. So if the requirement is fulfilled, if it is not getting fulfilled by the pump, then what will happen to the application? The crane or lift will feel certain jerks or vibrations. So for removing or reducing the vibrations and the shocks, we put the hydraulic accumulator, so that resultant vibrations and shocks are lesser, will be lesser. It can be treated as a safety device also. Yes, we are running in the lift. If the power supplied by the pump is not sufficient enough, then what will happen? It may cause danger. The lift may stuck in between the motion. So in that condition, if hydraulic accumulator is there, in that condition, that can be treated as a safety device. Okay. It can work as a reservoir. So it is similar meaning. It is storing the hydraulic energy. It can also be treated as a reservoir for the pressurized fluid. So these are the some functions, although we discussed all these things, but again in different form. If the question is asked, then we will be writing our answer in different format. Okay. Now we are coming to another application of hydraulic. So basically it is a lift. It is a very well known diagram related to the Pascal's law. So Pascal's law, what basically it is, as we all know, Pascal's law is what? It is a principle in fluid mechanics that states that pressure exerted anywhere in a confined incompressible fluid, confined. So this fluid is confined. The fluid in the lift, the fluid in between these two pistons is confined. And what is the property, what is the characteristic of this fluid? This is the incompressible fluid. For the Pascal's law, this is the necessary requirement. Fluid must be confined and it must be incompressible. What is then? Already I covered that Pascal's law in my previous videos, so I am not going in the detail. I am only reading the statement, I am only discussing the statement. So for a confined incompressible fluid, the pressure is transmitted equally in all directions throughout the fluid, such that the pressure variations remains the same. What is the meaning of this? It means the pressure at this point and pressure at this point, according to the Pascal's law, will be same. It means if F1 is the force applied through the piston and A1 is the cross section area here, so P1, the pressure at this side, is the F1 upon A1. Similarly, I can say the pressure on this side, where the larger cross section is there, is F2 upon A2. So according to the Pascal's law, it is P1 equal to P2. So F1 upon A1 equals to F2 upon A2. So by applying lesser amount of force, we can generate, we can produce more force on the side which is at higher cross section. So this is what the Pascal's law. Okay. So on the basis of this Pascal's law, on the basis of this principle, there are devices which are known as lift, hydraulic lift. So okay, the Pascal's law is clear. Now we are applying this principle to the where? To the purpose of lift, hydraulic lift. So lift, there are two categories of lift: direct acting hydraulic lift, another one is suspended hydraulic lift. Very simple, as the Pascal's law is simple, so the application is also very simple. But the Pascal's law is widely used for the hydraulic machine. So there are two categories of lift which are based on the Pascal's law. One is the direct acting hydraulic lift, second one is the suspended. What is the meaning of direct and hydraulic lift? Now I am coming to the point. Okay. First, I am coming to the diagram. From the diagram, it will be more clear. The name is direct hydraulic lift. It means the fluid is directly, the pressurized fluid is directly pushing the ram. Okay. So the liquid under pressure, from where it is coming? Obviously from pump to accumulator, and then from accumulator to lift. So this fluid is coming from the accumulator, high pressure fluid, and this high pressure fluid is pushing the ram of the lift. So obviously what will happen when the high pressure fluid is pushing the ram, which can be reciprocated in the fixed cylinder? So what will happen? Obviously this case will go up, and as the pressure is getting reduced, this case will come down. So this is what the hydraulic application, this is the hydraulic application lift. So now I am coming to the point. Now the point is very clear. So when a fluid under pressure is forced into the cylinder, the ram gets a push in upward direction. The platform carries, it means the cage which I told there, which is carrying the load. So the platform carries load or passengers, moves between the guides. As required height, it can be made to stay at that level with each floor, so that the goods or passengers can be transferred. That is what the purpose of lift. In direct acting hydraulic lift, the stroke of the ram is equal to the lift of the cage. So the working is clear. What are the basic components here? The basic components, as we can get, the fixed cylinder. So the cylinder is there in which the ram is reciprocating. Okay, the cage where the goods and passengers can be placed, which has to be moved up and down. Sliding ram, which we can say the piston, which is reciprocating in the fixed cylinder. So these are the basic components of the direct acting hydraulic lift. Again, I am making it clear why it is named as direct acting hydraulic lift, because the high pressure fluid which is coming from the accumulator is directly pushing the ram. There is no other arrangement. So very simple though. Again, the pressurized fluid is pushing up and down the motion of the cage. Another one is the suspended type. So in this suspended type hydraulic lift, the fluid is not directly pushing the ram. The fluid is not directly pushing the ram. It means it is pushing the piston, but not directly to the cage or the floor which is moving up and down. Then what will be here? Then by the name it must be very clear, this is the suspended hydraulic lift. And suspension of what? Suspension of wire, rope or pulley arrangement. So that is what the basic difference between the direct hydraulic lift and suspended hydraulic lift. So again I am coming to the diagram first. What it is here? Here we are observing that there is arrangement of two pulley. One pulley is fixed, another pulley is movable. And this movable pulley is connected to the ram, which is reciprocating in this fixed cylinder. Okay, and this complete arrangement of what? Two pulleys, one is movable, one is fixed, and one sliding ram and fixed cylinder. That is what known as jigger. Okay, so there is a certain arrangement. Okay, this arrangement you can see here. One, again I am putting movable pulley which is connected to the reciprocating ram. Another one is the fixed pulley, then the fixed cylinder. Okay, so here we are observing. So the high pressure fluid which is coming from where? Which is coming from the pump or from the accumulator. It is coming inside the line. This is pushing the sliding ram. So when the sliding ram is going towards the left, what will happen? This case will start moving upward. And as the supply of fluid is stopped, what will happen? This ram will come towards the fixed pulley and this case will come downward. So this is what the simple arrangement. Why it is named as suspended pulley, suspended lift? Because this case is suspended with the help of rope and pulley arrangement. So that is the difference. The fluid is not directly acting on the cage. It is acting on the reciprocating ram, which is reciprocating in the fixed cylinder. So that is the difference between this. So now I am coming to the point here. So working of the suspended hydraulic lift. When the fluid under pressure is forced into the cylinder, the ram gets reciprocate to the movable pulleys. With the help of arrangements of the hydraulic jigger, pulley can rotate. With the help of the wire rope and cage is maintained their pressure force with their floor. As required height, it can be made to stay at a certain level with each floor so that the goods or passengers can be transferred. So this is what the simple working. What are the basic components? The essential basic components are the cage. The purpose is clear. What is cage? The platform or the floor which is used for the purpose of what? Which is used for the purpose of shifting the goods and passengers. Wire and rope arrangement, that's why it is named as the suspended lift. So that is the wire and rope arrangement. Sliding ram, which is fitted in the fixed cylinder and attached with the movable pulley, which is reciprocating in the fixed cylinder. Pulley, obviously if wire or rope arrangement is there, then along with that pulleys will be there. So pulleys are connected to the sliding ram and fixed cylinder, where one pulley is fixed and other is the movable. Hydraulic jigger, as I told, the movable pulley, fixed cylinder and sliding ram, all these makes the complete arrangement is known as hydraulic jigger. And the fixed cylinder, where the high pressure fluid is coming and the ram is getting reciprocated. So these are the two hydraulic applications which I discussed today. One is the hydraulic accumulator, another one is the hydraulic lift. Hydraulic accumulator, that is the temporary store of hydraulic energy. So as and when it is required by any hydraulic application such as lift, crane or the press, then it will be delivered from the hydraulic accumulator. And the lift, that is nowadays a common feature everywhere. So there can be two kinds. One is the direct hydraulic lift, another one is the suspended type of hydraulic lift. And the application, the basic principle behind it is Pascal's law, which is very clear to everyone. So thank you very much for watching the video. Thank you.